Yeah, fine. Thank you. Yeah, very good morning to all. Today, again, we are entering into the third session of the class, that is operating system structures. So, before going to the detailed discussion about operating system structures, first of all, let us review what we have been done in the previous class. That is session two. In session two, what we happens is that computer system structures. So, in a computer system structures, what we have been seeing is that what is a computer? What are the various peripherals are there in a computer system? How these peripherals are connected using bus? What is a bus? A bus is a collection of three components: address bus, data bus, and control bus. And followed by the next topic, we have been seeing that what is an interrupt? An interrupt is nothing but a signal which is received by the microprocessor, indicating that communicate with the CPU. What are the different kinds of interrupts? How multiple interrupts can be handled by your CPU? And followed by the third topic, what we have been seeing in the last class, the modes of data transfer between CPU, memory, and IO units. That is done by using three methods. Number one, program control data transfer. Number two, interrupt initiated data transfer. Number three, direct memory access data transfer. Okay, and after that, what we have been seeing is that storage hierarchy. What are the different kinds of memories which is available in your computer system? What are the different kinds of memories which is available in your computer system? Okay, whenever the user is trying to execute any particular program, how your program is going to be distributed among all these particular memories to get faster. That implies the main goal of memory hierarchy is that we have to achieve the highest possible average access speed while minimizing the total cost of the memory system. And followed by the last topic in the last class is that protection. That is how your hardware is protected. CPU is protected by using timer control. Memory is protected by using base comma limit registers. And IO devices are protected by using dual mode operation. That's enough. This is what we have been seeing in the last class. Now we are entering into the core of the operating system, that is operating system structure. In this particular topic of discussion, what at glance, what we are going to see is that so whenever you want to design a new operating system, what are the various factors you need to be considered? What are the various programs you need to write? What are the different kinds of services you are expected from the operating system? These are the components what we are going to be see. Now, this topic is titled as operating system structures. So coming to the first one, okay. So before going to the detailed discussion about an operating system components, first of all, we look into that. Okay, there are several vantage points from which we can view an operating system. So how an operating system will going to be viewed by the user? What are the different kinds of things which is required to design an operating system? Now, coming to the basically, there are three very important things you need to consider while designing an operating system. First of all, what kind of services you are going to be expecting from the operating system? The first very important point is that what are the different kinds of services you are expecting from the operating system? The first very important one is what are the different kinds of services you are going to be expecting from the operating system? Number two, the second very important point is that whatever the services which is provided by your operating system, which is conveniently used by the user or not. It is a conveniently usable. Operating system is created for the purpose of convenience for the user. Already in the first topic of in the session one, we have been seeing that what is the main goals of an operating system is that number one is convenience for the user. Number two, efficient operation. Okay, that implies what is the meaning of this? Whatever the services which is offered by operating system that is conveniently used by user. That is the second one. And the third very important point, what you need to consider is that don't think that operating system is a single component. An operating system is a collection of components and their interconnections. Operating system is not a single program. An operating system is not a single module. It is operating system is a collection of components and their interconnections. Operating system is a collection of components and their interconnections. Okay, now first of all, first topic what we are going to see is that operating system components. That is, whenever you want to invent an operating system, whenever you want to invent an operating system, so what are the various components you need to consider is that number one, process management, number two, main memory management, number three, secondary storage management, number four, IO management, file management, production and security, networking, and command interpreter system. These are the various components what you need to consider before designing an operating system. First of all, you must know all these particular things before trying to design an operating system. So coming to the first topic of discussion is that, okay, process management. What do you mean by okay process? First of all, before going to detailed discussion about the various responsibilities of the operating system in connection with process management, okay, first of all, let you know that what do you mean by process? Okay, first of all, let us will define what is a program. A program is a set of instructions which is written by the user in order to achieve a particular task. A program is a set of instructions which is written by the user in order to achieve a particular task. The program is going to be stored on secondary storage device. The program is stored on secondary storage device. Whenever the user is trying to execute this particular program, first of all, the program should be copied into main memory. Whenever the user is trying to execute this particular program, this program should be copied into main memory. Once the program is copied in main memory, it is not called it as a program. It is called it as a process. That's why what is a process is just defined as its program under execution. Program in execution. That implies the contents of the process is stored in main memory. Contents of the process is going to be stored in main memory. Now I'll define you as the standard definition. A process can be defined as it is a program in execution. In order to execute such kind of a process, it may require resources like CPU cycles, memory cycles, and IO devices, so on and so forth. But all these particular resources are under the control of operating system. So before executing any particular process, first of all, you have to make a requisition to the operating system. I want these resources. Okay, now once an operating system has been granted these particular resources, you're allowed to continue your execution. In case, so once your execution is complete, again you have to return back all these particular resources to operating system. This is what is the standard definition of a process. The main difference between program and a process is that a program is a passive entity that is stored in secondary storage device. A process is an active entity. The contents of the process is stored in main memory. In order to execute such kind of a process, you may require several resources like CPU cycles, memory cycles, IO devices, so on, etc. Let us take an example. Whenever you're trying to execute any particular program, first of all, a program should be copied into main memory. That implies you first require main memory, and starting address should be placed on program counter. You require a program counter register. The program is executed by CPU. That implies you require a CPU. And in case if during the transaction of execution, during the execution of the program, in case it requires any input and output operation, then you require input and output devices. That implies in order to execute a particular program, in order to convert a program into a process, it required CPU cycles, memory cycles, IO devices, etc. But all these particular resources are under the control of operating system. So before executing any particular process, first of all, your process may request the operating system, I want these resources. So once this resource is available from the operating system, then it is simply sanctioned and allowed to execute. Once your execution is complete, again you need to return back all these particular resources. This is what is the main difference between program and a process. What are the various kinds of responsibilities of the operating system in connection with process management? So first one, the operating system is responsible for creation of a process. What do you mean by creation of a process? And it's simply, in order to create a particular process, whatever the set of resources which is going to be required. So what are the set of resources that they're going to be required? First of all, allocate all that particular resources. That is going to be called as creation of a process. Once the process execution has been successfully completed, again you need to return back all these particular resources to operating system. That is going to be called as deletion of a process. Allocation of a particular process, allocation of resources to a particular process is referred as a creation. And deallocation of resources particular process is known as deletion. Now, coming to the next very important, under that is an operating system is responsible for creation of a process. An operating system is responsible for deletion of a process. And coming to the next very important one, second kind of responsibility is that suspension and resumption of a process. Already from the previous class discussion, everyone knows that while executing a low priority process, whenever a high priority interrupt is encountered, the low priority process is preempted and the response is given to high priority process. Before preempting low priority process, first of all, you need to save the status of the current low priority process where it has been stopped somewhere in the stack, and you need to get to high priority. Once high priority process execution is complete, again you need to resume the low priority process where it has been stopped in the RDM. It is the duty of an operating system. Suspension of a process whenever high priority interrupt is encountered. Okay. And resumption of a process is also going to be done. Okay, once a high priority process completed. Once a high priority process completed. That is suspension and resumption of a process. And coming to the next very important, the third very important responsibility of an operating system is that process scheduling. What is process scheduling? Whenever multiple jobs arrive in the ready queue at the same time, your CPU cannot able to handle all the jobs at the same time. Your CPU can having a capability of executing only one job at a time. Then CPU can having a capability of executing only one job at a time. Then who is going to be decided that? That is decided by process scheduler. That is decided by process scheduler. Process scheduling. The process scheduling, the term refers to whenever multiple jobs are arrived in the ready queue, the CPU must be responsible for deciding that your CPU scheduler must be responsible for deciding which job is going to be executed next. Now, coming to the next fourth kind of responsibility of an operating system in connection with process management is process synchronization. What is process synchronization? Whenever data has been shared by more than one process at the same time, if you are not using any proper security mechanism for the data will going to be leaves you in inconsistent state. In order to overcome this kind of an inconsistent state, what are the set of techniques you are going to be uses? That kind of a techniques is going to be called as process synchronization technique. A process synchronization techniques are used for solving data sharing problems. There is simple definition. So in order to get a clear understanding about the students, we'll take a small example. Suppose one student is having an account in a bank with a balance of 2000 rupees. Now that student want to withdraw 1000 rupees from his account. But what the student does is that he has been written two checks, 1000 rupees, and hand out to another guy. And these two students went to the bank and tried to submit the checks at the same time at a different counters. What happens? Now, so first of all, the cashier one will see that how much balance is left in this user account. Then it shows on the monitor. Okay, it shows on the display screen as 2000. And similarly for the cashier 2 also it shows only 2000. And what cashier does is that it simply makes it 1000 rupees subtraction from this value, 1000 subtraction from that value from the both cashiers, and ask him to save. Then what happens is that first of all, first cashier is done, issued a save. Then it overwrites the old value 2000 is overwritten with 1000. The second cashier is also done the same thing, 1000. After withdrawing 1000 rupees by student 1 and student 2, then how much balance we have? That is only 0, but the balance is 1000 rupees. This is a fault transaction. It is not allowed. So at a time, that particular cash balance is accessed by only one transaction at the same time. How can you overcome this particular problem? The best technique is that we use locking technique. So before executing any particular process, what are the set of resources which is going to be required? First of all, make a lock on that. So once the lock is obtained, you're allowed to continue the execution. Once your transaction is successfully completed, you need to release the lock. Suppose if already student one makes a lock on it, if second student is simultaneously make a transaction on the same, okay, user balance, then the operating system simply tell you, sorry, some transaction is going on, you please wait. Then once so user one transaction is successfully completed, the lock is opened and the updated value is reflected to student two. Then the only balance shows that 1,000, sorry, insufficient balance for withdrawing money. That's enough. This is going to be called as process synchronization. Whenever a data item is going to be shared by multiple users at the same time, if you're not using any proper security mechanism for the data will going to be enters into inconsistent state. Okay, in order to overcome such kind of an inconsistent state, what are the set of techniques you are going to use is going to be called as synchronization techniques. Now, student one is making a lock on it. The student two has to be wait until the lock has been released. How much amount of time he has to wait? So there is no. Then we use process communication. A communication is a set of techniques which can be used to exchange the data between the processes. That is communication. And coming to the next one, deadlock handling. Your operating system is also responsible for deadlock handling. Just now, I have been defined what is a process. A process can be thought of as it is a program under execution. In order to execute such kind of a process, it required resources like CPU cycles, memory cycles, and IO devices, etc. But all these particular resources are under the control of operating system. So before executing any particular process, first of all, you have to make a requisition to the operating system. I want these resources. Whatever the resources you are requested, if it is not available from the operating system, then what happens? Then operating system simply asks you to wait. There may be a chance that this wait state is not going to be changed forever. Hence, it is going to be called it as a deadlock. Hence, it is called it as deadlock. How can you define a deadlock? A continuous waiting state of a particular process is known as a deadlock. A continuous waiting state of a particular process is known as deadlock. So, in order to understand better understanding of a student, now I'll give you another example. Suppose my computer system has been equipped with one tape drive and one printer. Both are non-shareable devices. At a time, only one person can handle it. So there are two processors running, P1 and P2. In order to execute that particular process, both P1 and P2 require tape drive and as well as printer. Now, process P1 simply comes and make a lock on tape drive, and process P2 make a lock on printer. Then what happens? Process P1 is holding tape drive and waiting for the printer, and process P2 holding printer and waiting for the tape drive. Then both processes are not allowed to continue the execution. Hence, this particular situation is called it as a deadlock. Now, I can define another way of a deadlock is that in a multi-programming environment, more than one process is competing for resources. In case if any process is holding some set of resources and waiting for the resources held by some another process. Similarly, that process is also holding some set of resources and waiting for the resources held by this process. Then both processes are not allowed to continue the execution. Hence, this particular situation is going to be called as deadlock. And then this particular situation is going to be called as deadlock. That's it. These are the different kinds of responsibilities of an operating system. These are the different kinds of responsibilities of an operating system in connection with process management. That implies if you want to design a new operating system, if you want to design a new operating system, if you want to invent an operating system, in that, okay, the total operating system has been divided. Everyone knows that according to the software engineering, a project is not developed as a single module. It should be divided into number of modules. In module 1, process management, module 2, memory management, module 3, secondary storage management, so on up to like this. Again, each and every module, if the complexity is high, again it should be divided into some module. This is called as modularization. This kind of a concept is called as modularization. So when you want to design an operating system, so first of all, what you need to do is that you need to write one module for process management. In that process management, you need to write a set of programs. One program for creation of a process, one program deletion of a process. You need to write another program for suspension of a process, and the resumption of a process. You need to write a program for process scheduling. You need to write a program for process synchronization. You need to write a program for process communication. You need to write a program for deadlock handling. You need to write a program for deadlock handling. Deadlock handling. That's it. These are the various kinds of responsibilities of an operating system in connection with process management. And Coming to the next very important, okay, main memory management. Second very important component in an operating system is the main memory management. The second very important component is that implies if you want to invent an operating system, if you want to invent an operating system, so you need to write another module for main memory management. So what are the various kinds of responsibilities of the operating system in connection with main memory management? What are the various kinds of responsibilities of operating system in connection with main memory management? So here everyone knows that the basic principle of you see, is whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. Where you need to copy the program? We need to copy the program. So that implies wherever the space is available, you need to copy that. And you need to check that whether the space is sufficient for running your program or not. That is the second very important. And the third one, if multiple processes are trying to enter into memory, you need to give a priority. Who is allowed to occupy in memory, who is not allowed. That's it. By seeing all this particular theory, you can understand that. So your operating system must be responsible for keep track of which parts of the memory is full and which parts of the memory is empty, and which parts of the memory is used by whom, okay, and which processes has to be loaded into memory. Once a program is trying to execute, first of all allocate a memory. Once program execution is successfully completed, you please do it right. Okay. Okay, this one. That is, your operating system must be responsible for three kinds. And you need to write at least three programs. So, first program, keep track of which parts of the memory are currently being used by whom. The second, decide which process is to be loaded into memory when memory is available. Number three, allocate and deallocate memory space wherever is needed. These are the different kinds of responsibilities of operating system in connection with main memory management. So, in case if you want to design an operating system, you need to write one module for main memory management. In that, you need to write three programs. One program is for keep track of which parts of the memory is full and which parts of the memory is empty. And second program, you need to decide which process to be loaded into memory. And you need to write another program for allocating and deallocating of memory. And coming to the third very important module in an operating system is that secondary storage management. Okay. Main memory is simply a volatile storage. Once the power is turned off, whatever the content that is there in the memory simply vanish. If you want to see any particular data permanently, it should be kept it on secondary storage devices. That is hard disk, floppy disk drives, drums, CDs, etc. These all devices are comes under the category of secondary storage devices. Now, if you want to see any particular data permanently, then it should be kept it on secondary storage device. Now, so what are the various kinds of responsibilities of operating system in connection with the secondary storage management? Okay, so first of all, so it is okay. Number one, free space management. Whenever you want to store any particular data on a hard disk or a secondary storage device, first of all, you must know that which part of the hard disk is full and which parts of the hard disk is empty. That implies your operating system is responsible for keep track of which parts of the hard disk is full and which parts of the hard disk is empty. Your operating system is responsible for which parts of the hard disk is full and which parts of the hard disk is empty. And coming to the second very important one is that storage allocation. So before trying to map any particular data onto secondary storage device, first of all you try to see that whether the space is sufficient for or not. Okay, that is decided by storage allocation. Storage allocation is simply allocating whatever the amount of memory which is going to be required to store your particular data. That is decided by this one. And coming to the third very important responsibility of an operating system in connection with secondary storage management is the disk scheduling. So what is this particular disk scheduling? Whenever multiple jobs are trying to be storing the data on the hard disk at the same time, your hard disk, okay, so hard disk on the same platter, you can do only one job at a time. Why? Because each and every platter is connected with one read write head. If multiple jobs are trying to thrown on a same platter at the same time, so you need to decide which job is first and which job is second, which job is third, so on like this. Thus can decided by disk scheduling. So whenever you want to design an operating system, so you need to write one module for secondary storage management. In that module, you need to write at least three programs. One is for free space management, that implies keep track of which parts of the hard disk is full and which parts of the hard disk is empty. And you need to write another program for allocation of memory, storage allocation. You need to write another program for scheduling the jobs onto secondary storage device, which is referred as disk scheduling. And coming to the third, the fourth very important component is that IO system management. The next very important concept is IO system management. Okay, this is very important. Why? Because your CPU has to be frequently contact with the input output devices. So what are the various responsibilities of the operating system in connection with IO management? Okay, input output system management. The coming to the first very important one is that okay, so first of all, your operating system must be keep track of what are the different kinds of device drivers that are already installed before trying to use that particular IO device. So your operating system responds for maintaining all device driver programs, all device driver programs for the operations of every IO device. Already from the previous class definition, we have been defined what is a device driver. A device driver is a small program which knows that how to control the status bits, flag bits, and operation of the specific device. It is the duty of the operating system to keep track of all the device drivers for every specific to hardware devices. Why? Because whenever a new device has been connected to your computer system, first of all, it must be detect, yes, new hardware has been found, that driver is already there. If the driver is not there, immediately it tells you that I cannot handle this particular input output device. Why? Because I cannot know how to handle the operations of this device. Okay, for example, if you put any particular pen drive or any USB port, immediately on the bottom of the screen you are getting USB port has been detected. Okay, that implies your operating system has been identified a new device with a device driver. In case if the device driver is not there, immediately it tells that the USB is not recognized or that particular CD drive is not activated. You are getting such kind of message. And coming to the last responsibility of an operating system in connection with IO management is that buffer caching system. So what is buffer caching system? So any kind of IO transfers is always routed through only buffer. Okay, a buffer is a part of main memory. A buffer is a part of main memory where your IO operations are going to be done. And each and every IO device is also maintain a small amount of buffer which can be used for transferring data in a queue manner. Okay, that is buffer caching system. This kind of a detailed discussion is going to be happen in the next topic of discussion. Now coming to the next one, these are the, and in case if you want to invent any operating system, in case if you want to design any operating system, you need to write one module for IO system management. In that you have to write at least three programs. One program is for buffer caching system, one program for maintenance of device drivers, and one program is for mapping device driver programs to hardware device. And coming to the next very important component in your operating system is that file system management, or you may simply call it as file management. So what is a file? Let us will define the technical definitions. Okay, non-technically everyone can say that what is a file? A file is nothing but it is a collection of records. A record is a collection of field. A field is a conceptual tool for representing data. Okay, let us take a hall ticket number of a student is one field, name of a student is one field, age of a student is one field. Hall ticket number, name, age, all together is called as one record. Collection of these particular records is going to be called as file. That is what is a file, non-technically. Technically, what is a file? A file is a collection of records, must be kept it on a secondary storage device, is going to be called as file. Or you can define it as a file is a collection of records must be mapped onto a non-volatile storage medium. Mapped onto non-volatile storage medium. This kind of a thing is going to be called as file. Okay, now when files concept is going to be, whenever the user want to see any particular data permanently on secondary storage devices, then he has to be used files concept to transfer or to read the data from the secondary storage devices. That is what is file management. So simply I can define as a file is a collection of data which is stored on a non-volatile storage medium. So what are the various kinds of responsibilities of operating system in connection with process file management? Before going to the responsibilities of the operating system in connection with file management, let us will see. Suppose for better understanding, I'll tell you a small example. Okay, suppose you have been written one file today. Okay, you have been opened one document. You have been opened one document, something. You have been typed entire information, whatever you like. It is named as something kk.doc. It is named as kk.doc. And the next day, if you come and simply, if you open kk.doc, then immediately it opens it and show you how it is done. How it knows that where this kk.dot file is stored on secondary storage device. It is the duty of operating system maintaining a fact table, file allocation table. So whenever we are trying to retrieve any particular information from a book, first of all, we check that we check it in index. If the topic is available, then we'll find out what is the page number, and then we are directly move to the page number and we'll retrieve the content whatever we like. In a similar manner, whenever the user want to retrieve any particular data from the secondary storage device, that is from hard disk. So first of all, your operating system looks into fact table. So the file allocation table, fact table stands for file allocation table. That file simply contains what is the name of the file, when the file has been created, when it is lastly updated, what is the size of the file, where it has been located, who is the user, what kind of permissions is having. This file related information is completely stored in your fact table, that is file allocation table. So the next day, if you come and open for a kk.doc file, kk.doc file, it immediately went to fact table. It immediately went to fact table and checks that where this particular file is available, and it simply pick up the address and simply open it and show. This is how it is going to be happen. Simply, it is how we are going to be pick up an information from a book by seeing an index. So a book is having an index, a hard disk is having a fact table. Simple. That's it. Okay. What are the various kinds of responsibilities of an operating system in connection with file management? The various kinds of responsibilities of an operating system in connection with file management is that number one, creation of a file. Number one, creation of a file. Creation of a file in the sense, first of all, you need to search for where the space is available in the hard disk. If the space is available, allocated, that is call it as allocation of a space for a particular file is called it as creation of a process. And once a file is deleted, allocation, creation in the sense, you need to make an entry, not only allocating space in secondary storage device, you need to make an entry in fact table. It is the duty of an operating system, whenever a new file has been created, the particulars of the file, the details and parameters of the file has been recorded on fact table. Why? Because next time searching is going to be done based on fact table only. Now coming to the second very important one is that deletion of a file. Suppose if you want to remove any particular file, okay, simply you're deleting the file, that's it, by pressing a del key. But what happens? Your operating system is responsible for removing an entry from the fact table. Okay, operating system is responsible for removing an entry from the fact table. Removing an entry from the fact table. Removing an entry from the fact table. That is similarly. So your operating system is also responsible for creation of directories and deletion of directories. What is a directory? Everyone knows that a directory is a collection of files. Your operating system is also responsible for handling primitives for manipulating files and directories. So what are the different kinds of parameters? Just we have been seeing what is the name of the file, what is the extension of the file, when the file is created, when the file is last updated, what is the size of the file, who is the owner of the file, what kind of permissions, read, write and execute. These all primitives has to be maintained by your operating system. Now, and fourth kind of responsibility of the operating system is that mapping of files onto secondary storage. Whenever the user has been press the key, call it as save, then whatever the data which is entered on that editor, this all data has to be mapped onto secondary storage device. It is the responsibility of operating system. Now, in case if only, and the operating system is also responsible for maintaining backups. What do you mean by backup? If the original file is lost in unavoidable circumstances, we can recover such kind of a data by using backup copies. These are the various kinds of responsibilities of the operating system in connection with file management. That implies whenever you want to invent or design an operating system, You need to write one module for file management. In that file management, you need to write one program for creation of files. You need to write one program for deletion of files. You need to write another program for creation of directories, deletion of directories, primitives for manipulating files and directories, how to map the data which is entered on the editor. This should be mapped on the secondary storage and back. These are the various kinds of responsibilities of operating system in connection with file management. And coming to the next very important one is protection and security. What do you mean by protection and security? Of course, this topic is already been dealt in the last class. Okay, again I'll review. What do you mean by protection? Okay, in order to improve the performance of the CPU, we have been introduced multi-programming concept. In order to improve the performance of the CPU, we have been introduced a concept of multi-programming. So multi-programming in the sense more than one program is simultaneously reside in memory and they are simultaneously they are executed. Now, while executing one particular process, how can you protect the resources which is handled by this process from other processes, which is referred as protection. That's why the protection is simply defined as, it refers to a mechanism for controlling the access of programs or processes or my users to the resources defined by computer system. Just now I have been defined what is a process. A process is thought of as it is a program in execution. In order to execute such kind of a process, it requires resources like CPU cycles, memory cycles, IO devices, etc. Now, these all resources, how are you going to be protected from one process to another process, which is also going to be handled by your operating system itself. That is going to be called as this one. Okay, that is protection and security. Already we have been seeing how your devices is protected in the last class. Hardware protection. Okay, hardware protection in the sense the CPU protection is done by using timer control. Memory protection is going to be done by using base and limit registers, and IO protection is done by using dual mode operation. And coming to the next very important responsibility of the operating system is that networking, that is distributed system. Already everyone aware that, already we have been discussed about this topic. There is multi-processor organization. More than one CPU can be simultaneously reside on a same machine. They are closer to communicate. In order to establish the communication between the processors, if they are using same clock pulses and same buses and same memory, it is called a parallel system technology. In order to establish the communication between the processors, if they are using separate clock pulses, separate buses and separate memory, then it is going to be called as distributed system. So the distributed system is completely maintained by your operating system itself. Now, command interpreter system. The last component of your operating system is the command interpreter system. It is a very, very important, which is simply command interpreter system is a program which is acting as an interface between a user and the operating system. There is a mediator which must be required to communication between a user and the operating system. Okay, the user has been given some sort of commands. These commands has to be interpreted and given to CPU how to execute this. This is going to be done by command interpreter system. Simply its job is that get the next command and execute it by the CPU. Get the next command and execute it by the CPU. This is going to be called as a system. So whenever you want to invent any particular operating system, what are the different components you need to consider is that process management, main memory management, IO management, secondary storage management, file management, protection and security, networking, and command interpreter system. So you need to divide your operating system module into 8 modules. Every module is internally having sub-modules. This kind of doing a particular project is going to be called as modularization. This is going to be called as architecture of an operating system. Everyone knows that in software engineering. Now we'll move on to these are the various components of an operating system. Now we move on to second topic, operating system services. The second very important topic of discussion is that operating system services. What are the different kinds of services which is provided by your operating system? What are the different kinds of services which is provided by your operating system services? Just now we have been gone through what are the various components of an operating system. These all components, operating system is created or designed for the purpose of convenience of user. That implies whatever the components which is provided an operating system that every component is a service used by user. So, before going to the detailed discussion about this particular topic with the different headings, we can simply say that what are the different kinds of services which is provided by operating system that implies it process management services, main memory management services, IO management services, secondary storage management services, um, file management services, protection security, command interpreter system, networking. These are all components of an operating system as a services to user. That's why simply we can take that what are the different kinds of operating system services in a sense. You can simply tell that what are the components are there. Everything is for the convenience of user. But now we'll study it as different names. What are the different kinds of services provided by operating system by providing all the components, that is process management, memory management, etc. The first very important service provided by your operating system, the first very important service provided by the operating system is that program execution. What is this particular program execution? Operating system is creating an environment for the user to executing his programs in a more convenient fashion. Already you know that in earlier days, whenever the user is trying to execute any particular program, the user is completely what struggle they have been faced. There has to be written the program in machine language, punched and punched cards, everything. The lot of struggle has been taken. Today we are not doing anything at all. Simply if you want to run a program, we are simply the operating system providing an editor for us, then we are typing the program, and after that by pressing F9 key, the program is translated. By running control F by pressing control F9, you are running the program. Everything is on your fingertips. Yes or no? Who is providing all this? It is provided by your operating system. So, operating system is creating an environment for the user to executing his program. That's why the first chapter we have defined as also a definition. One of the definition of operating system is that an operating system is creating an environment for the user to executing his programs in a more convenient fashion. Number two, the second very important service of an operating system is that IO operations. Okay, what is this IO? Input-output operations is managed by your operating system itself. Input-output operations is also managed by your operating system itself. So when you press a key on a keyboard, actually suppose if you press a X on the keyboard, what happens? Through wire, okay, only signals are going to be transmitted to your motherboard. Then after receiving this particular signal, it should be decoded by the device driver and it should be appeared on the monitor as X, sorry. Should be appeared on the monitor as X. Who is translating all this? Who is handling this? This is done by your operating system. This is done by your operating the system. It is done by your operating system. All IO operations are going to be handled by your operating system. Suppose let us take you are taking a printout on a paper. The data is in memory in the form of machine language. Machine language. When you take a printout, it is going to be in human readable format. Okay, who is doing this? This is done by your device drivers. It is under the control of operating system. So your IO devices operations are completely handled by your operating system. And the third very important kind of service is that file systems. So what is this particular file system? What is this file system service? Just now we have been saying that whenever the user want to see any particular data permanently on the secondary storage devices, then only we are going to use the concept of files. So that file system service is also provided by your operating system. It will allow you to see your data permanently in future. And the fourth kind of service of an operating system is the communication. Okay, in providing communication facility, it is providing a communication facility for exchanging information between the processors, users, etc. And an operating system is responsible for providing another service is going to be called as resource allocation. Already we have been seeing The standard definition of an operating system is that operating system is simply defined as controlling the resources and allocating the resources are brought together into a single piece of software is known as operating system. Controlling the resources and allocating the resources are brought together into a single piece of software is known as an operating system. That's why we can also call it as an operating system is also a resource provider. Why? Because what are the set of resources are there in your computer system? These all resources are under the control of your operating system. So the beautiful point is that even your CPU is also under the control of operating system. CPU is not boss in our computer system. Operating system is the boss. Okay, and operating system is also responsible for accounting information. What are the set of resources are there, and which resources are used by whom? Presently, which resources are idle and which resources are completely full. This kind of information is maintained by your operating system. And coming to the next very important service provided by your operating system is the error detection. During the execution of an operation of any process, if any error is encountered, it immediately detected and displayed for the user for making correction and continue the execution. This is also done by your operating system. And your operating system is also providing protection and security services. So now can you see, this is process management, IO management, file management, communication management, resource management, error detection, production security. These are all components of an operating system itself, but I have been used at different headings. That's it. These are the different kinds of services provided by operating system at a glance. Okay, so what are the different kinds of services offered by your operating system in the sense? Number one, operating system is program execution, IO operations, file manipulation, communication, error detection, resource allocation, accounting, protection, and security. These are the different kinds of services which is offered by your operating system. Okay. Now coming to the next very important one is that system calls. The next very important one is system calls. Now before entering into this particular topic, again we'll try to see the definition of a process. What is a process? A process can be thought of as it is a program under execution. In order to execute that process, it required resources like CPU cycles, memory cycles, IO devices, CPU registers, etc. But all these resources are under the control of operating system. So before executing any particular process, first of all, you have to make a requisition to the operating system. I want these resources. Once the resource is granted, you are allowed to continue the execution. Once your execution is completed, you need to return back all these particular resources to operating system. Now you observe, your process may need a lot of communication with an operating system. Yes? Yes or no? Yes. In order to execute a particular process, your process may need a lot of communication with an operating system. Your process may need a lot of communication with operating system. Yes or no? Yes. So how a process is going to be communicate with an operating system? A process will communicate with an operating system by using system call. By using system call. What is a system call? A system call is simply defined as interface between, acting as an interface between process and the operating system. In order to execute a particular process, a process may need a communication with an operating system. How a process will going to be communicate with an operating system? The process will going to be communicate with an operating system by using a system call. That's why the system call is simply defined as it is an interface between a process and the operating system. How the system calls is available? Generally, these system calls are available in assembly language, instructions, and usually they are listed in manuals by assembly language programs. Or today we are also having this particular system calls is also available in C language. Why? Because today modern operating systems, all today whatever the operating systems you are seeing in the market is all C operating systems has been designed in C language, in designed in C language, designed in C language. Now coming to the next very important one is that so let us take a small example of a system calls. A system call is simply a call to an operating system from a process. That's it. Let us take an example. Copy the contents of one file to another. Copy the contents of one file to another. Suppose I want to copy the contents of one file to another file. Let us say kk.txt to mm.txt. Some content is there on kk.txt. I want to copy the contents of kk.txt into mm.txt. What I need to do? First of all, I need to open kk.txt in read mode and mm.txt in write mode. By using fread command, I need to read one character from kk.txt. By using fwrite command, I need to write one character onto mm.txt. And once this is done, I need to close the kk.txt file pointer. I need to close the mm.txt file pointer. This is what technically we'll do in C language. Now, first of all, you need to open a file. Yes. In order to open a file, the file management is under the control of operating system. All files are under the control of operating system. Your file is located on secondary storage device, but your all hardware devices are under the control of operating system. So first of all, you need to make a requisition to the operating system. I want to open this particular file. That is a system call. First of all, you're asking an operating system, please open kk.txt file in read mode. That is a system call. And I open a file mm.txt in write mode. That is a system call. Then after that, fread is a system call to operating system. Fwrite is a system call. Why? Because fread in the sense you need to read one character from the hard disk, but hard disk is under the control of operating system. That is a system call to your operating system. That is, and after that, close the file. Close the file. That implies you need to close the contents and make an entries in fact table. Who is doing? The fact table is under the control of operating system. So that whatever the operations you are doing, every operation is a system call to operating system. You are not directly allowed to do any particular operation. It must be mediated through an operating system itself. That implies every time you need to make a lot of communication with an operating system. The communication is happened by using system call. That's why the system call is simply defined as it is an interface between a process and an operating system. Now, just you observe it from the previous example, copy the contents of one file to another file. Just I am trying to tell you, open a file kk.txt. I am calling a function open by sending a parameter kk.txt. Yes. Now, I open a file similarly, open a file with mm.txt. I am calling a function system call open by sending mm.txt. That implies your operating system is receiving some parameters from the operating system. Sorry, from the processes. Your operating system is receiving some parameter from the processes. Okay. So what are the different ways of passing parameters to operating system? What are the different ways to pass the parameters to the operating system? Okay, what are the different ways of passing parameters to operating system? There are three ways of passing parameters to operating system. Number one, registers. Why? Because the fastest memory in your computer system is a register. If any data is placed on register, so that your operating system will quickly read that information and make an action. The main purpose is to keep the CPU busy at all the times. In case if the parameters are high, so register cannot accommodate. Why? Because your computer system is equipped with a very less number of registers. Your computer system is equipped with very less number of registers. Then at the time what we are using is that a block of storage What are the parameters are there? These all parameters are stored in memory, main memory, but the starting letters of the parameter, the storage area is put on register and supplied to CPU, supplied to operating system make an action. Otherwise, you can use stack organization. What is stack organization? So you know what is a stack? A stack is a last in first out data structure. The lastly inserted element is always removed first, where insert, delete operations are restricted at only one end, which end is called as top end. Whenever you want to insert an element which is allowed on the top end, whenever you want to delete an element which is also allowed from the top end. The insert operation into a stack is known as push. The delete operation from the stack is known as pop. This is stack organization. So we have got one question in GATE. What are the different ways of passing parameters to operating system from a process? A, by using registers. B, by using block of addresses with starting address specified in register. C, stack organization. D, all of the above. Answer is all of the above. This is how we are present. The block of addresses are kept in main memory. The starting address of the parameter is placed in a register, and from that we can call. Now, coming to the next one, what are the different categories of system calls? What are the different categories of system calls? Just now we have been saying what are the various components of an operating system: process management, memory management, IO management, secondary storage management, and so on up to etc. Okay, in a similar manner, what are the different categories of system calls in a sense? Process management system calls, file management system calls, device management system calls, information management system calls, communication system calls. Only a small change. That is, we can categorize as process control system calls, file manipulation system calls, device manipulation system calls, information maintenance system calls, communication system calls. Now in detail we'll go for it. Now, so process control system calls related to process management. So we call it as process and job control system calls. So what are the different kinds of system calls which is available from an operating system? Okay, available from a process to communicate with an operating system. What are the different system calls available for a process to communicate with operating system? The various system calls under process management is: number one, creation of a process. Creation of a process in the sense you need to allocate all the resources. Who is going to be allocate the resource? Your operating system. So first of all, creation of a process in the sense it is a system called an operating system. Please allocate the resources. Once the process execution is successfully complete, then what you need to do? You need to return back the resources to this one. Then operating system is responsible for taking all the resources. It is also a system call terminate a process. And is a system call simply stop the execution of the process. Under that implies end in the sense the program execution is successfully completed, the resources must be returned back. Abort, forcibly stopping the execution of a particular process. That implies whatever the resources which has been allocated to them taken by your operating system. And form, loading a process is a system call. Executing a process is a system call. Get process attributes is a system call. Set process attributes is a system call. Wait for a time. Wait for time. Suppose in case if any data is shared by multiple users at the same time, if the data is locked by another person, you need to wait some amount of time until the lock is open. That is also a system call. Wait for an event is a system call. Signaling an event, the task is done. Allocating a memory is a system call. Releasing a memory is also a system call. These are the different kinds of system calls which are available in connection with process and job control. And coming to the next very important one is file manipulation system calls. Next one is file manipulation system calls. So creating a file, in the sense you need to allocate a space in secondary storage device and make an entry in fact table and record all the parameters associated with that file in fact table. Who will do this? Operating system itself it will do it. That's why creating a file is a system call. Deletion of a file, you need to remove that entry from fact table. Who is removing? Your operating system is removing. That implies system call to operating system. Opening a file is a system call. Closing a file is a system call. Read, write, reposition, getting, setting attributes. Everything is a system call. That implies whatever the operations. Hmm. So whatever the operations you are going to be doing, that everything is in terms of system calls. And coming to the next very important one is device management system calls. What is device management? Requesting a device is a system call. Suppose if you want to make a printer, then you need to ask the operating system whether the printer is idle or not. If it is not idle, ask him to put the job in queue. Releasing a device. Once operation is completed, again you need to release the device. Suppose you plug in a pen drive, what operating system does? Yes, an USB port has been detected. That is done by requesting a device. Before removing USB, what you need to do? You need to tell that operating system, I am removing this. Then operating system tell you that safely remove. That is whatever the operations which has been done is actually recorded. You can eligible for reading from a device is a system call. Writing onto a device is a system call. Repositioning a device is a system call. Getting device attributes is a system call. Setting device attributes is a system call. Logically attaching a device is a system call to the operating system. A new device, today we can attach any devices directly while running a system. Earlier it is not possible. It is operating system dynamically detecting what are the devices which has been attached and detached. And coming to the last one, information maintenance system calls. What is information maintenance? Okay, we'll see another one, communication system calls also. Information maintenance system call. So your computer system has been displayed on the bottom. What is the date and time and everything is displayed. So this date and time is going to be completely maintained by whom? Even the system is turned off, again it is going to be displaying the current time and date. How it is possible? Your computer system is having one motherboard. In the motherboard we have one battery, call it as CMOS battery, complementary metal oxide semiconductor battery. Okay, so in motherboard there are several registers and ROMs are there, but these are going to be continuously required some power. So this all power is going to be getting from CMOS battery. So the time maintenance, setting a time on the hardware device, getting system data, setting the system data on the hardware, setting set process attributes, file, device attributes, everything is a system call. Everything is going to be kept track of by your operating system. And coming to the last very important system calls is that communication system calls. The last one is communication system calls. So creating a communication connection is a system call. We are going to be create a communication connection. Your operating system is responsible for creating a communication connection. Once a communication is happened, you need to disconnect it. Who is disconnected? Your operating system will disconnect it. Suppose if I'm connected to an internet, okay, the creation of a connection is done by your operating system. Once I have come out, the deletion of it done is also done by your operating system. Sending a message is a system call. Receiving a message is a system call. Transferring of status information is a system call. Attaching and detaching remote devices is also system call. Now, before going to the detailed discussion about the rest of the topic in this, we'll go into what are the different kinds of communication mechanisms are there between processes. There are two kinds of mechanisms. Number one is going to be called as a message passing model. Number two is going to be called as shared memory model. Number one is message passing model. Number two is going to be called as shared memory model. Now, what is a shared memory model? Now, coming to the first very important one is that message passing model. Whenever, let us see, you can observe in this diagram, there are two processors running your computer system. This is a kernel. Kernel is nothing but where your operating system is running. Already I have been given a standard definition for an operating system. One program is always runs in the system kernel, which is known as operating system. So whenever you have been switch on a system and you can switch on a system, And before switching on, one program is always runs in the system kernel at every moment of time is called it as operating system. That implies one program is always resident in memory, that is operating system. Where operating system is resident in memory, that area is going to be called it as kernel. A kernel is a part of main memory where your operating system is running. Now, whenever a process A want to send any particular piece of information to process B in message passing model, the process A sends that information to first of all an operating system. Operating system in turn sends that information to process B. If a process A want to send any particular piece of information to process B, first of all, process A sends that information to operating system. Operating system in turn sends that information to process B. Not directly possible. A process cannot directly communicate with each and every other. The intermediary between these two guys is an operating system. And coming to this one, second kind of model is going to be called it as shared memory model. So what is shared memory model? So now you can observe it. This is process A, process B, and this is a common area of process A and process B, which is shared between this one. Whenever a process A want to send any particular piece of information to process B, the process A simply put that information in shared memory. Let's say a process B will read that information from shared memory. Simple. Process B reads that information from shared memory. That's it. Then this kind of mechanism, there is no intermediate between. Intermediate action is between these two processes by an operating system. But what happened is with this model is that memory protection is failed. This is an area which belongs to both process A and process B. Already you know that in the earlier examples, memory protection is done through base comma limit. So while executing process A, so process A may get a confusion that operating system, your CPU may get confusion that whether this area now it belongs to process A or it belongs to process B. That's why we are always most probably will prefer only message passing model. Okay, this is end of this discussion about this topic. Now we'll move on to the next topic, system programs. Now we'll move on to the next topic, system program. So what are the different, what is a system? Okay, already in the first class I have been defined, okay, what is an operating system? An operating system is simply defined as it is a collection of system programs. It is a collection of system programs. Operating system is simply defined as it is a collection of system programs. So what are the different kinds of system programs you have? In the first topic itself, I told that if you want to design an operating system, so what are the various programs you need to write? In the sense, you need to write one program related to process management. You need to write some set of programs for memory management, so on up to like this. Now, what are the different kinds of what is the different kinds of system programs in the sense? Number one, file manipulation system program. If you want to do file manipulations, you require some programs. That is file manipulation system programs. These programs will create, comma, delete, copy, rename, print, dump, or list, generally manipulate all the files and directories. Status information system program. These programs simply ask the system for date and time and amount of memory which is available, which is responsible for accounting information. That is status information. And file modification. Several text editors may be available to create and modify the contents of the file stored on disk and tape. These all are going to be maintained by your file modification. Programming language support. In order to execute your programs, you require compilers, assemblers, loaders, linkers. These are all maintained by your operating system itself. Next, program loading and execution. So whenever the user is trying to execute any particular program, first of all, a program should be loaded into memory. And starting address is given by program counter and an instruction to the CPU to start execution. This is also one program. And communication programs. Next one, communication programs, email maintenance. These are all comes under the category of communication. Finally, application program. Okay, most of the operating systems are supplied with programs that are usable to solve common problems, or you may call it as perform common operations such as formatting packages, database systems, spreadsheets, Excel, PowerPoints. These are all application programs. Collection of all this is going to be called as system programs. These are all going to be called as system programs. So finally, I conclude this particular topic. How? Uh, in this topic, what we have been seeing is that four major components: system, operating system components, operating system services, system calls, and system programs. All are same only. Components are becomes as services. The services are available using system calls. These all services are written by using the programs are known as system programs. So if you get a question like this, system programs or system calls or operating system, all are same only. Yes. This is the end of the discussion about the third topic. Now we're going to be move on to the next topic of discussion is process management. Now we're going to be see the next concept of discussion is the process management. In this process management, totally we're going to be see the four different topics. Number one, process. Number two, process scheduling and threads. Number three, process synchronization. Number four, deadlock handling. These are the four topics what we're going to be see in this particular topic. Now, process management. In this, first we'll take process. First we'll take process. So before going to the detailed discussion about process, first of all, let us will define what is a process and what is a program. What is the difference between program and a process? So first of all, already we know that from the previous topic, a process can be thought of as program in execution or program under execution. In order to execute such kind of a process, it may require resources like CPU cycles, memory cycles, and IO devices, etc. But all these particular resources are under the control of operating system. So before executing any particular process, first of all, you make a request to the operating system. I want this particular resources. Once this request is done by means of system call, and after that, CPU will allocate all the resources for executing your process. Once your execution is complete, and again you need to return back all these particular resources to operating system by using the system call. This is how it. Then already from what are the various kinds of responsibilities of an operating system in connection with process management? In the sense, number one, creation of a process. Number two, deletion of a process. That is, allocation of resources to a particular process is known as creation of a process. Deallocation of resources is going to be called as deletion of a process. Suspension of a process, resumption of a process. Okay, that is suspension and resumption in the sense, while executing a low priority process, whenever a high priority interrupt is encountered, the low priority process preempted, the response is given to high priority process. But before preempting low priority process, first of all, we need to save the status and again of the current process and loading a new process, and after executing a new process, again you need to resume it. This is called as suspension and resumption of a process. Your operating system is also providing the provision mechanisms for process scheduling. Your operating system is also responsible for providing provision mechanism for process synchronization, process communication, and deadlock handling. These are the various kinds of responsibilities of operating system in connection with process management. So coming to the first very important topic of discussion, there is process concept. This concept is demonstrated by using Three fundamental focusing areas. Number one, process. Number two, process state. Number three, process control block. What is a process? What is, first of all, before going to the detailed discussion about this one, first of all, we must know what is the difference between program and a process. A program is a set of instructions which is written by the user in order to achieve a particular task. A program is written by user. The contents of the program is going to be stored on secondary storage, a device. So whenever you are trying to execute this particular program, first of all, the program should be copied into main memory. First of all, the program should be copied into main memory. Once program is copied in main memory, then it is not called it as a program. It is called it as a process. So that's why a program is resides on secondary storage device. It is called it as passive entity. A process is called it as active entity. Why? Because which is stored in main memory. Now, in order to convert a program into a process, the program should require several resources like CPU cycles, memory cycles, I/O devices, CPU registers, etc. Once this particular all resources are allocated to a program, then the program is converted into process. The program is converted into process. That's why we call it as a process is defined as program under execution. Okay, program is converted into process while executing. Okay, now once a program is now, okay, now can anyone ask me whether program and process both are same? No, program and process both are not same. Let us take a small example for this. Suppose you have written a small simple C program. Hello, welcome. Hash include stdio.h, void main, begin, printf, hello, end. Now, if you try to run this program, what happens is that this program should be copied into main memory. Okay, the first line of the program is hash include. What is hash include? It is a preprocessor directive. It is the direction to the compiler. Before loading my program, first of all, copy the contents of stdio.h into main memory. The total entire stdio.h is going to be attached to your program. That's why program and process is not going to be same. Why? Because why it is attached in the sense, whatever the keywords you have been used internally, these all keywords meanings are exist in stdio.h. That's why it is called as preprocessor. Before processing the program, first of all, process the contents of standard input output header file. That's why it is preprocessor. That's why program and process both are not equal. And another very important, beautiful point is that a process, a program, while converting into a process, it is divided into two sections. While converting a program into a process, it is divided into two sections: text section, data section. Suppose you written a program in C language. So now, if you are trying to execute this program is copied into main memory. Before copying into main memory, this program is divided into two sections: text section, data section. The text section contains the total machine language translation of the source program. The text section contains the total machine language translation of the source program. The text section contains the total machine language translation of the source program. And data section contains what are the list of variables you have been declared. What are the list of variables you have been declared? What are the list of variables you have been declared? These all variables are going to be getting space in data section. So text section contains the total machine language translation of the source program, and text section contains the list of all variables, whatever the data you have been defined, these all are going to be exist in the section. Why it need to be divided into two like this? This is for sharing of text segment is done. Let us take a small example for this. We are also getting one question in GATE like this. What is this? Suppose if you open an MS Word document for typing your biodata. Now one document is open. So now there are one document is open and you are typing your biodata. Internally, it is maintained as two different sections. One is MS Word software program. Second one is your biodata. Data is there in this one. Suppose if you want to open another document and type something else, then you need to open another document. Again, no need to run the same text, another text document. The text document is already there. The document 2 is also share the same text document with the different data. Suppose if you want to open another one, okay, it's eligible. You can open another third document with the same text document. Now, one text document is shared by several data sections. This is going to be called as segment sharing, or may call it as page sharing, you may call. Okay, we'll see that kind of a techniques in memory management. That is, text sections are equivalent and data sections may be vary for some processes. That's why we are dividing them into two sections. Now, coming to the second very important topic is that process state. Second very important one is process state. So, what is a process state? Your process just all of you please observe this particular diagram just short while. I'll come back just one minute. So the next topic is process state. So while executing a process, or you may call it as during the execution of the process, your process may be reside in any one of the following 5 states. Your process may reside in any one of the following 5 states. So what are the different states of a particular process? Number 1, new state. Number 2, ready state, running state, waiting state, and terminated state. These are the 5 states of a particular process. So coming to the first one, new state. The process being created. That is, whenever a new process has been created by your operating system, that is, once the resource is allocated to that particular process, then it is going to be called as new state. And after that, that implies these all jobs are resides in your ready queue. The set of all jobs which are resides in ready queue and waiting for the CPU is known as new states. But your CPU is not having a capability of, again I'll come back. Okay, the total number of process states is defined as 5. Coming to the first one, new state. The set of all jobs which are resides on secondary, I have been spelled wrong. Okay, please make a correction on this. The set of all jobs resides on secondary storage device is going to be called as new state. Those jobs which are willing to come into memory, which jobs are willing to come into memory, that particular jobs are going to be called as new job, new state. But these all jobs will not going to be admitted into main memory. Why? Because your main memory is having only sufficient amount of small amount of memory. Your main memory is having a small amount of memory. So only some of the jobs which are selected and it is going to be kept in main memory. Once these particular jobs are kept in memory, it is going to be called as a ready state, which is called as ready state. This is called as a ready queue. And after that, among all these particular jobs, the CPU will not going to execute all the jobs at the same time. The CPU can having a capability of executing only one job at a time. So currently, which job is going to be executed by your CPU is called as running state. If the running process is successfully completed, it is entered into terminated state. While running this particular process, in case this job is required as an any IO operation, then simply that job is going to be handed over to IO processor, and the CPU does not sit idle. It simply selects some another job from the ready queue and executes. Then the waiting state of a particular process. This is waiting for an IO operation. Once IO operation is completed by your IO processor, then again this job is put back onto ready queue. Now currently whatever it is going to be executed by your CPU, it simply forcibly stop the execution and giving the control of the CPU to old stopper process. Why? Because the old stopper process always gets a first priority. The old stopper process always gets a first priority. Now, so how can you explain this? We can explain by means of a small example. So first of all, I'll give you the standard definitions of every state, and after that we'll link it with one example so that you can clearly understood what is the state of a particular process. The set of all jobs which are residing on secondary storage device and they are willing to come into main memory is called as new state. The set of all jobs which are resident in main memory in ready queue for execution, waiting for the CPU are known as ready state. Currently, which job is going to be executed by your CPU is called as running state. Now, currently, which jobs are waiting for to complete an IO operation is called as waiting state. Those jobs which are successfully completed are called as terminated state. That implies. Now we'll see. Initially, there are 20 jobs are there in secondary storage device. They are all willing to come into main memory. 20 jobs are there. The 20 jobs are going to be called as job pool. But these 20 jobs will not, according to the basic definition, whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. Now, among these 20 jobs, only 5 jobs can be allowed to copy into main memory. Why? Because memory is sufficient for only these 5 jobs. Then your job scheduler must be, this is called as job pool. This is called as job pool. The set of all jobs which are residing on job pool is called as new states. That is, those who are willing to come into main memory is going to be called as new state. Is going to be called as new state. Now, some of the jobs from the job pool is selected by job scheduler and copied into main memory. In main memory, it is going to be called as process queue or may call it as a ready queue. The set of all jobs which are resident in main memory in a ready queue is going to be called as a ready state, and they are ready for CPU. They are waiting for CPU. Now, among all these particular 5 jobs, there are 5 jobs are in ready state, 20 jobs are in new state, 5 jobs are in ready state. But your CPU cannot having a capability of executing all these 5 jobs at the same time. Your CPU is having a capability of executing only one job at a time. Then your CPU scheduler select one job from the ready queue and executing it. Which job is currently executed, which is going to be called as running state. Which is called as running state. In case if the running job is successfully completed, then it is going to enter into terminated. Terminated state in the sense whatever the resources you have been allocated, you please try to hand over these all resources to operating system. While running a process, in case this job is requires an IO operation, according to multi-programming, CPU does not sit idle. It simply switches from one particular job to another job. It simply switches from one particular job to another job. Simply, this currently running job is handed over to IO processor. CPU take another job from the ready queue and executing it. And meanwhile, the IO processor will execute IO operation. Once IO operation is complete, again the job is again put under ready queue. Ready queue in the sense they are waiting for CPU. Then what CPU does is that whatever currently that is going to be executed, it is forcibly stopped and giving the control to old stopper process. That is the event IO event has been completed. Now, why? Because you know that every old stopper process always gets a first priority. Old stopper process always gets a first priority. That's it. That's why there is forcibly whenever an interrupt, that is high priority interrupt is encountered, the running process is forcibly kept to ready state, and those job which is already completed IO, again scheduler dispatch will start the old stopper process. That's these are the 5 states of a particular process. These are the 5 states of a particular process. Is it clear, everyone? Can I need to give any example for this? Suppose, let us take an example. 20 people came into my in front of my chamber to talk with me, but my chamber is not have a space for 20 members. It is having a capability of 5 members can accommodate. Then my room assistant, well, my peon will going to be simply select 5 members. That is the 20 people who are willing to communicate with me are called as mule state. Among these 20 people, 5 people are selected by my peon. He is a job scheduler and they are allowed to sit in my room. That 5 guys are called as ready states. And after that, I am not having a capability of talking all the 5 people at the same time. I am selecting one person by using CPU scheduler and I am talking with them. I am talking to the person. That person is called as in running state. If the person is successfully completed his task, ask him to leave the room, which is going to be called as terminated. That implies leave the room in the sense leave the chair, make it empty, and so that another person will come and sit there. That is reallocation of resources. While running a process, while running that particular job, I am asking that person fill the particulars of some. I have been given some paper to ask him to fill the particulars. The person is filling the particulars. Meanwhile, I am not sitting idle. I am selecting one person from another in this room and I'll talk with them. After completion of this task of this person, again he'll come back, sir, my work is finished. Then simply what I do is that I stop the present executing person and giving response to the old one. That's it. This is going to be called as process state. So that's why this is known as multi-programming. Already I told that what is multi-programming? Interleaved fashion of execution. Giving a look and feel that all the jobs are going to be happening simultaneously. Interleaved fashion of execution. Giving a look and feel that all the jobs are going to be happening simultaneously. This kind of a concept is known as multi-programming. So that is next. We'll move to the third topic of discussion is that process control block. Okay, from the previous definition, you have been seen that your CPU is frequently switching from one particular process to another process. Yes, everyone is, I hope everyone is agreed. Okay, why? Because according to multi-programming, more than one program can be simultaneously resided in main memory during the execution of one program. In case if any program requires an IO operation, the CPU does not sit idle. It simply switches from one particular job to another job. So CPU is frequently switching from one particular job to another job. How can the CPU can knows that? How far? How so far I have been executed? Where I have been left over? Where I need to again start this particular process? How can a CPU how your operating system will do this? Okay, that is while switching from one particular process to another process, already you know that before switching from one particular process to another process, it need to save the status of the current process where it has been stopped somewhere in the stack, and you need to switch it to that particular process. Okay, so where all these elements are stored? Okay, that is done by using PCB, process control block. Your process your CPU is frequently switching from one particular process to another process. How can it is switching? How can it is restoring the status? How can it continue the execution wherever it has been left out in the earlier? Is all done by means of process control block. See, what is a process control block? In process control block, what are the different kinds of process control block? Now, so that is before switching from one particular process to another process, okay, it is saving all the particulars in process control block. So coming to the first one, process state. Just now we have been seeing that the state of a particular process may be either new, ready, running, waiting, and terminated. Currently, what is the status of your process? There are several processes which is running on your computer system. Each and every process is identified by your operating system by using process ID number. That is process number. Okay, each and every process is going to be identified by using one number known as process ID number, and followed by the next one, program counter. What is program counter? What is program counter? A program counter is a special type of register which is initially contains the starting address of the program where your program execution is going to be started, and after that it contains what is the next instruction is going to be executed. Program counter is a special type of register which initially contains the starting address of the program where your program execution is going to be started. Where your program execution is going to be started. And after that, it contains what is the next line is going to be. So, before switching that, you need to save the status of the program counter value. Why? Because again, while you coming back, you need to start the execution from this place. That is, the program counter is always specifies what is the next instruction is going to be executed in this process. Now, next very important one is CPU registers. So what are the different kinds of CPU registers which is used by your process, and what is the contents of each and every register? Already I told you, in order to execute a particular process, it requires resources like CPU cycles, memory cycles, IO devices, etc., and CPU registers. So what are the different registers used by this process for running? What is the contents of that particular registers are going to be there in this. And next one, memory limits. What is memory limits? Whenever you know the basic definition, okay, whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. So in main memory, which area you have been copied your program, what is its base value and what is its limit value, that everything is going to be stored here, and followed by what are the list of files you're already open. What are the list of files you're already open for executing this particular process. And another very important thing is here in these three dots, so we have a pointer is there. What is this pointer in the sense? Pointer pointing to next process control block to be executed after executing this particular process. These are internally maintained in the form of a linked list. You know what is a linked list? A linked list is a collection of nodes, and each and every node is consisting of minimum two parts. The first one is information, second one is a pointer pointing to the next node. We have another very important here, pointer, which is pointing to the next process to be executed here. These are the various components of process control block. This is ends of the discussion about process concept. The process concept is demonstrated by using process, process state, and process control block. Now, coming to the next topic of discussion is that process scheduling. Next very important one is process scheduling. What is this particular process scheduling? What is this particular process scheduling? This concept is again demonstrated on three dimensions. First of all, we look into what are the different kinds of queues that is available in your computer system. What are the different kinds of schedulers are there for scheduling these queues? how your process while switching from one particular to another one, saving and restoring is going to be done by while switching from one particular process to another process. Saving and restoring is going to be done by one particular program known as context switch. In this particular three dimensions, we are going to see this particular topic. Coming to the scheduling queues. So first of all, what are the different kinds of queues are available in your computer system? The different kinds of queues available in our computer system is that number one, job queue. Already I told that job queue in the sense that a set of all jobs which are reside, the set of all jobs which are reside in secondary storage device is going to be called as job queue. The set of all jobs which are going to reside in secondary storage device is going to be called as job queue. Only some of the jobs are going to be selected from job queue by the job scheduler and copied into main memory, which is going to be called as a ready queue. Under the set of all jobs which are ready for execution, which are waiting for the CPU to be selected, which is going to be called as a ready queue. This job selection is done by process scheduler, or may call it as CPU scheduler. And we are also having IO device queues. Okay, each and every IO device maintains one queue. So suppose it's hard disk queue, tape drive queue. So whatever the set of IO devices we have in your computer system, these all queues are maintained in the form of linked list. That is linked queue concept. Okay, now already we got one question in GATE examinations. How do you get? What is the suitable data structure for maintaining scheduling queues? What are the different data structures are maintaining for scheduling queues of IO? The best one is linked queue. The best one is linked queue. You know that what is a queue? A queue is a first in, first out data structure. The firstly inserted element is always removed first, where insertions are restricted from rear end and deletions are restricted from front end. Okay, such kind of a data structure is going to be called as a queue. That is. Now coming to the next one. Can you see in this particular diagram you can observe? Okay, this is a ready queue. Ready queue in the sense the set of all jobs waiting for the CPU to be executed. We are having like this. Okay, so first one, header, pointer pointing to the first process control block, so on up to pointer pointing to the next process control block, so on up to like this. Okay, and this is a magnet tape unit. No one is waiting for magnet tape unit 0. Magnet tape unit 1, no one is waiting for it, but so many 3 people are waiting to schedule by desk unit. They're all connected using linked list. Okay, there is one process is waiting for the terminal unit. So this is how we are going to be maintained in the form of queues. So linked queue. Now coming to the second topic of discussion is that process scheduling. Process scheduling. Okay, now already we have been seen process state diagram. This is a Gantt chart representation of process state diagram, nothing else. It is the same, but we'll get a questions on this. That's why I'm talking again this particular topic. So the set of all jobs which are resident in main memory is called as ready queue. The set of all jobs which are resident in main memory is called as ready queue. The CPU will going to be select one job from the ready queue and execute it. Currently, these are all ready state. Now, currently, which job is executed by the CPU is known as running state. While running this particular process, in case if an IO operation is encountered, what is done is the sense that IO request is going to be put it on IO queue, the corresponding IO device queue, which is going to be executed by IO processor. Meanwhile, the CPU does not sit idle. It selects some another job and executing it. After some amount of time, IO processor, this is indicate IO processor, you may also call it as GMA. After IO processor schedule this particular job. Once the scheduling is done and execution is done, again this particular job is put back onto ready queue. Once this particular job is put back on ready queue, whatever currently that is executed by your CPU, it simply stop the execution and giving the control to this old software process. Already you know that the old software process always gets a first priority than currently what is executing. So the scheduling decision may be done. Scheduling decision has to be done once a job is come into ready queue after completion of IO operation. Number two, suppose if you go for a time sharing operating system. So in the first session, we have been seen that in time sharing operating system, a small one CPU is going to be shared by several processes at the same time. The CPU will dedicate a small amount of time on each and every process for executing. So how much amount of time which has been spent for executing the particular job is called it as time quantum, or may call it as time slice, or may call it as time slice, or may call it as time slice, or may call it as time slice. Okay, so within that particular time quantum time, the job may be completed, may not be completed. If it is completed, well and good, there is no problem. If it is not completed, it again possibly put in a job queue, that is sorry, ready queue, and CPU select the next job. You'll go automatically next, so on. Now, while executing one particular process, you may call it as a parent process. In case the parent process invokes another process, that is called it as a child process. Now, the parent process execution is now stop until the child process has to be completed. Once the child execution is complete, again this process is going to be put back into ready queue for scheduling. Now, while executing a low priority process, whenever a high priority interrupt is encountered, immediately the low priority process is preempted and the response is given to high priority process. Why? Because high priority interrupt is always service first. Okay, so this is already you have been seen in the previous diagram. That is, whenever an interrupt is came, forcibly stopping the execution of currently whatever you are executing, simply put back onto ready queue and select the currently interrupted one. That is, this is going to be called as process scheduling. This is the concept of process scheduling. And coming to the last topic of discussion for today is that schedulers. The last topic of discussion for today is schedulers. So what are the different kinds of schedulers are there? What are the different kinds of schedulers? So already you understood that you have a job queue. There are a set of jobs that is resident in secondary storage device. Not all the jobs are eligible to come into main memory. Only some of the jobs which is selected from job queue and copy into main memory. That is called as ready queue. Who is responsible for that? I had told that earlier, that name is job scheduler. Now I am going to call it as long-term scheduler. Okay, job scheduler, or you may call it as long-term scheduler. A long-term scheduler is a small program which is responsible for selecting some of the jobs from secondary storage device to main memory, or you may call it as it is selecting some of the job from job queue to ready queue. So yeah, now ready queue is having a set of jobs, but your CPU is not having a capability of executing all the jobs from the ready queue at the same time. So your CPU is having a capability of executing only one job. Who will decide that which job is going to be executed next? That is decided by short-term scheduler. That is defined by short-term scheduler, or may call it as CPU scheduler, or may call it as process scheduler. All the same. Process scheduler. Okay, so process scheduler is a program which is responsible for selecting one job from ready queue and supplying to the CPU and make the CPU busy at all the times. Now, coming to the next one, what happens is that the processes are mainly classified into two categories. Number one, CPU bound process. Number two, IO bound process. Whatever the processes you are executing in a computer system, these processes are classified into two categories. Number one, CPU bound process. Number two, IO bound process. CPU bound process in a sense, if it is spending the most of the time for execution with the CPU than IO processor. You already know that every computer is having minimum two processes. One is CPU, second one is IO processor. Now that particular process is spending most of the time with CPU than IO processor, then such kind of a process are known as CPU bound process. That implies you may simply call it as number of CPU cycles is greater than number of IO cycles. That is, suppose you written a program 100 lines, and among these 100 lines, okay, the input output statements is only 5 to 10%. Rest of the 90 lines program is completely a logic you have written. Then such kind of a programs are called it as CPU bound processes. Therefore, suppose if you write a program 100 lines, among these 100 lines, Only 90 lines are only printf, scanf, input, output statements. Only calculation statements is only 10. Such kind of a process is known as IO1 process. What is IO1? It is spending most of the time for executing the IO processor than CPU. It is spending most of the time for doing IO operations than execution. That's such kind of a process are going to be called as IO processes. That is, number of IO cycles is greater than number of CPU cycles. Now, what happens is that if the long-term scheduler, okay, okay, long-term scheduler, while selecting jobs from secondary storage devices to main memory, if he selects all the jobs are CPU bound jobs, then what happens is that otherwise you can take, in case a long-term scheduler selecting all the jobs, either IO bound process, what happens? The CPU is sitting idle most of the time. CPU is going to be sitting most of the time idle if a ready queue is completely filled with either CPU bound process or IO bound process. Why? Because let us see. Suppose if you are long-term scheduler, select all CPU bound processes. What happens? Okay, the CPU is, I told that the CPU is very extremely fast device. It can having a capability of executing millions of instructions for a small fraction of a second. So whatever the jobs you are already loaded in memory, it takes only a fraction of moment to execute all the programs. Again, the CPU is sitting and waiting for when the next jobs will going to come into memory. That is what happened. Suppose if you load all IO bound process into memory. While executing one process, IO operation is encountered, CPU saving the status and switching to some other process. While executing the second program, in case this is also requires an IO operation, CPU save the status and move to third process. The lot of CPU cycles are wasting for saving and restoring the status of a particular process. That's why the throughput is completely down. In order to improve the performance, small mistake, this is not short-term scheduler, this is long-term scheduler. Okay, this is now long-term scheduler is now replaced with long-term scheduler replaced with medium-term scheduler. Now long-term scheduler is replaced with medium-term scheduler. Long-term scheduler is replaced with medium-term scheduler. So what is this medium-term scheduler? Medium-term scheduler is a small program which is responsible for selecting a good process mix from secondary storage device to main memory. That is job queue to ready queue. That is job queue to ready queue. Then the idleness of the CPU is reduced. So what happens is that, so suppose if you select some jobs CPU bound and some jobs IO bound, what happens is that CPU bound jobs are going to be cleared and it is removed. Meanwhile, CPU does not sit idle. It's execute all IO bound processes. In that particular time, your medium scheduler brings some another CPU bound process into memory. That implies simultaneously in and out is going to be done so that the throughput is improved. That implies throughput in the sense the number of jobs that is completed on a given unit of time. That's it. So now coming to the move on to this one. So the last topic of discussion today is that context switch. What is this particular context switch? What is this context switch? So the context switch is a program which is responsible for saving and restoring the status of a particular process. Already I told that before swapping out a particular program from the memory and after bringing IO, after completion of IO operation, before bringing into memory, we need to save and restore has to be done. That is going to be done by whom? That is context switch. That is done by a program known as a context switch. What is this context switch? A context switch. So that implies, let us say, while executing a particular program. So if the program is currently not recovered in memory, it's simply swapped out from the memory. So after some amount of time, IO operation is completed. Again, the job, it is scheduled by IO processor. Again, it put back onto ready queue. That is swapped in. The processes is again swapped in. So saving and restoring using PCB. Who is going to do this? This is done by context switch. It is done by context switch. Okay, swapping is a small program which is responsible for removing a process from the memory storing back onto disk, and bringing back from the disk to continue the execution. This is going to be done by a program known as swapping, or by call it a swapper. So context which is responsible for saving and restoring the status of a particular process. This is how it is going to be done. This is completes our discussion about today. So today what we have been seen is that what is process? A process concept is discussed in three dimensions: process, process state, and process scheduling. And after the process control block, and we haven't discussed about process scheduling, which is also discussed in three dimensions: scheduling queues, schedulers, and context switch. So this is completes our discussion about today, and the rest of the topic we're going to will deal in the next class. Okay, thank you one and all. Yeah, are you there? Yeah. Yeah. Okay, fine. Now if the video is now visible. Okay, then fine. Thank you.